Welcome to lesson 6.3. We're going to be dividing polynomials. This is going to seem like it's totally out in right field as a topic compared to the other stuff we've been working on. But this skill we're going to use when we're solving polynomials in future lessons. So that is the point of what we're doing. The objective is we're going to learn how to divide polynomials using two different methods. Those two different methods are long division, which follows the exact same pattern as the long division that you learned at some point in lower school when you did long division with numbers. We're going to do long division with polynomials, but it's the same process. So that's why example 1 in a moment will be long division with numbers, because we're going to review that process. The second way is what's called synthetic division. Synthetic division is easier and faster. So you might be saying, why wouldn't we just learn that and skip long division? And there's two reasons why we're going to do long division, even though synthetic division is better. And first reason is you need to understand the long division to understand synthetic division. So that's why we're going to spend some time doing some examples of long division before we do the synthetic division, because I want you to understand what you're doing when you're doing the synthetic division. And the second reason is synthetic division doesn't work for everything. There are specific polynomials that you can't do synthetic division with, and we'll talk about why and when that happens. So for that reason, when we get to the end of the lesson, I'm going to suggest doing synthetic division for everything that you can do, and then knowing how to do long division for the ones that you can't. Like I said, example 1 here is doing long division with numbers. So let's see if we remember how to do long division with numbers. First step is taking the divisor and seeing how far it goes into the first number of the dividend. How many times, right? 6 goes into 7 one time. That's really just division. So the first step is divide. Then we do 1 times 6 is 6, and that's multiply. Then we do 7 minus 6 is 1, that's subtract. Then you bring down the 4. Those 4 steps you repeat until you run out of numbers. Those are the exact same 4 steps that we're going to do with polynomial long division in the next example. But let's finish it off. 6 goes into 14 twice. 2 times 6 is 12. Subtract, and you get 2. Bring down the 5. 6 goes into 25 4 times. 4 times 6 is 24. Subtract, and you get 1. Bring down the 8. 6 goes into 18 3 times. 3 times 6 is 18. Subtract, and you get 0. When you get 0 there, that means there is no remainder, and the answer is 1,243 in this case. For part B, 5 goes into 6 one time. 1 times 5 is 5. Subtract, and you get 1. Bring down the 4. 5 goes into 14 twice. 2 times 5 is 10. Subtract, and you get 4. Bring down the 7. 5 goes into 47 9 times. 9 times 5 is 45. Subtract, and you get 2. At this point, the 2 is the remainder. So there's 3 different ways that you learned how to deal with that. You can either say it's 129 remainder 2, or you can say the answer is 129, and you take the remainder of 2 and put it over the 5. So it's 129 and 2/5 as a mixed number, or you can take that 2/5 and make it a decimal. Right? So all 3 of those are the same thing. What we're going to do really when we do polynomial long division on the next slide is we're going to leave it as a remainder, just like the first one. Easiest way to do it. We will eventually look at what to do when you leave the remainder as a fraction over the divisor. But that also requires us to do a whole other chapter of dealing with variables in fractions or rational functions. And then we're not going to do decimals at all. But anyway, primarily in this lesson, we're just going to leave the remainder as a remainder. Okay. This is a first look at example C. Here's a first look at dividing polynomials. 7x squared divided by x. How many times does x go into 7x squared? That might be a little harder to think about than 5 into 6, right, being 1. So write it out, 7x squared divided by x. The x's cancel, and you just get 7x. When you do the process, 7x times x would be 7x squared. You subtract, you get 0. So 0 remainder. Okay. Let's look at example 2, where we're really going to do some real polynomial division. If you're dividing this by this, that means when you set up as long division, x minus 3 is the divisor, x squared plus 3x minus 12 is the dividend. When you do that first divide step, remember the first step is divide. You're only looking at the first term of the divisor and the first term of the dividend. How many times does x go into x squared? In other words, it's x squared divided by x. If you take an x out of both, the answer is x. So we're going to put that linear part of the quotient above the linear part of the dividend. Now we multiply. X times x is x squared. X times negative 3 is negative 3x. Now we subtract, right? Again, same steps. Really important you put parentheses around what you're subtracting because you need to remind yourself that you're subtracting both of these terms. This is the place where if a mistake happens, it's going to be here. Okay? I'd say 99% of the mistakes that happen on any of these types of questions, any of these long division questions, happens on the subtract part. When I subtract x squared minus x squared is 0. That should always happen. If you do the divide and multiply parts correctly, this part should always be nothing. Then 3x minus negative 3x is 6x, because you're subtracting a negative. It'd be real easy just to add them together and get 0, right? But that's where the mistake would happen. Okay, now you bring down the negative 12. X goes into 6x 6 times, so plus 6. 6 times x is 6x. 6 times negative 3 is negative 18. Subtract. That's 0. Negative 12 minus negative 18 is like negative 12 plus 18, so 6. And again, we're just going to leave that as a remainder. So the answer to part A here is x plus 6, remainder 6. Okay. Let's go over here and look at this one. Very similar setup. It's this divided by this. So the x minus 5 is the divisor, and x squared plus 2x minus 30 is the dividend. How many times does x go into x squared? It's x times. X times x is x squared. X times negative 5 is negative 5x. When you subtract, that's 0. 2 minus negative 5 is like 2 plus 5, so 7x. Bring down the negative 30. X goes into 7x 7 times. Again, if you need to write it out, I could have written out the other one. You need to write them out, write them out. X's cancel out. It's just 7. Since it's positive, I did that. Since it's just positive, it's plus 7. Then 7 times x is 7x. 7 times negative 5 is negative 35. When you subtract negative, well, 7x minus 7x is 0. Negative 30 minus negative 35 is like negative 30 plus 35, so 5. So the answer to this one, the quotient, is x plus 7, the remainder of 5. Okay. I'm going to skip C. You can try that one on your own. That very well could be part of your exit ticket. I do want to focus on D because there's something about D that's a little different. If you notice, I mean, it starts with a much higher degree, right? X divided by x minus 1, that is the divisor that goes up front. It's really important if you notice, you got 4th degree, 3rd degree, and then linear, right? We're missing a quadratic. We need a placeholder. You can't do this with a missing term. So you got 4x cubed, x to the fourth plus 4x cubed, we're going to write plus 0x squared, and then minus x minus 4. Now when I do the first divide step, it's how many times is x going to x to the fourth, right? So that x cubed is going to go here. When I multiply x cubed times x is x to the fourth. X cubed times negative 1 is negative x cubed. When I subtract, that's 0. 4 minus negative 1 is 5. So 5x cubed. And I bring down the 0x squared. How many times does x go into 5x cubed? Write it out if you need to. And you get 5x squared. So I'm going to write plus 5x squared here. Part of the reason why you need that placeholder is you need a place to put that part of your divisor, part of your quotient. 5x squared times x is 5x squared, 5x cubed. 5x squared times negative 1 is negative 5x squared. And the other reason is you need it to bring it down so you have something to subtract this step from. 5x cubed minus 5x cubed is 0. Let me do that for now. And then 0x squared minus negative 5x squared is positive 5x squared. Now you're going to bring down the negative x. How many times does x go into 5x squared? Write it out if you need to. It's 5x times. So then 5x times x is 5x squared. 5x times negative 1 is negative 5x. When you subtract, that minus that is 0. Negative x minus negative 5x is like negative x plus 5x. And you get 4x. You bring down the negative 4. X goes into 4x 4 times. 4 times x is 4x. 4 times negative 1 is negative 4. So when you subtract this part, you do get 0. So there is no remainder on this one. And the quotient is x cubed plus 5x squared plus 5x plus 4. I'm going to come back to this after we do synthetic division. And the reason is you're going to want to do synthetic division with this. So we'll practice our synthetic division with example 3. So we're actually going to skip example 3 and jump over to, these are all example 3, synthetic division. And actually, this is labeled, whatever. I guess we got 2 example 3s on the slides here. Synthetic division, a simplified process of dividing by a linear factor. And again, we'll go back to those examples. So just skip ahead in your notes to this part and we'll go back. Looks like the exact same question because it is the exact same question, but this is an easier way to do it. What you're going to do is start with a half box. And you're going to put your divisor in here, but it's only going to be numbers. And if your divisor is x plus 1, you're just taking the opposite of whatever the sign is there. So if it's plus 1, then we're going to put a negative 1 here. The other way to think about the number that you're going to use as your divisor is the number that you'd substitute in for x to make that 0. Okay, so that's the number that goes in that box. Now we're going to list out the coefficients and the constant. Only numbers. So 3, negatives count, so negative 4, 2, and then negative 1. Then you're going to put a line underneath, leaving yourself enough room to put a number above that line and below that line. The first thing you do is just drop the first number. So that 3 drops down. Negative 1 times 3 is negative 3. Now you add down. You're not subtracting, you're adding. Negative 4 plus negative 3 is negative 7. Negative 1 times negative 7 is 7. Add down, you get 9. Negative 1 times 9 is negative 9. You add down, you get negative 10. This is your answer. It's just a matter of putting it back together now. I like to draw a line here because that number there, that last number is your remainder. So we're going to write from right to left. It's kind of weird. That number is your constant, so I'm just going to write a 9. It's positive, so it'd be a plus. That negative 7 represents your linear term, so it's negative minus 7x. And then that 3 represents your quadratic term, so 3x squared. And that's your answer. 3x squared minus 7x plus 9, remainder negative 10. If we had done long division with this the way we did in example 2, you would have the same answer. It's just a way easier process. It's less time consuming. I think also less mistakes happen because you're adding and not subtracting. The reason why you can add and you don't need to subtract is because you're taking like when you take the opposite here, now when you add the opposite every time, because you're multiplying that number through each cycle, when you're adding the opposite now, which is subtraction. So, but it still makes that step easier. Let's refresh how to set this up. Remember, divisor, if that's +1, you put a -1 here. When there is no coefficient, it's a 1. That'd be a 4, that would be a 1, and then -6. You want to just make sure that you don't get those numbers too close together and you don't think it's like a 14, right? It's a 1 and then a 4, they're separate. So just make sure you're spacing your numbers out. Drop the 1. -1 times 1 is -1. Add down, you get 3. -1 times 3 is -3. Add down, you get -2. -1 times -2 is 2. Add down, you get -4. Again, go from right to left. That's the remainder. That's the constant, so -2. That's the linear, so positive 3x. And then that's the quadratic, so just x squared is fine. Same thing here. Dividing by x -3. So remember, it's the opposite of whatever's happening there. So the number that will go in the box will be +3. Then you put the 5, the -6, the 4, and the -1. You drop the 5. 3 times 5 is 15. You add down. -6 plus 15 is 9. 3 times 9 is 27. You add down, you get 31. 3 times 31 is 93. You add down, you get 92. So that's the remainder. That's the constant. That's the linear term. That's the quadratic term. Notice here this one looks a little different because this is shorter. You're also missing 2 terms, right? You're missing the quadratic and the linear. So after I make the divisor, that's +3, so you put a -3 there. X cubed is 1. There is no quadratic term, so you need a 0. There is no linear term, so you need a 0. You need those placeholders. And then 27 is the constant. If you skip those placeholders of zeros, you will not get it right. You drop a 1. -3 times 1 is -3. You add down, you get 0. No, you don't. You get -3. -3 times -3 is 9. You add down, you get 9. -3 times 9 is -27. You add down, you get 0. So this one has no remainder. When that's a 0, that means no remainder. So I'm not even going to write remainder 0. I'm just not writing a remainder at all. Constant's 9. Linear term's -3x, and then x squared. So x squared minus 3x plus 9. Okay, I think we're going to go back. Yeah, so before we do remainder theorem, let's go back and do the example that we skipped. And what's going on here is it says use long division. We're going to use synthetic division for this to find factors of the polynomial. So the question simply is x plus 4 a factor of this? And then is it a factor of this? Well, we're going to do the division. And you could do long division or synthetic division. Since you could do both, I'm suggesting doing synthetic division. And quite simply, the answer is yes, x plus 4 is a factor of this if it has 0 remainder. X plus 4 is not a factor of this if it has any other remainder, right? A remainder of anything other than 0. So that's it. You're just going to do synthetic division, and the answer is yes or no based off of the remainder. So let's do it. -4 in the box. Then you go 1, 6, 8. You drop the 1. -4 times 1 is -4. You add down, you get 2. -4 times 2 is -8. You add down, you get 0. All I care about is this. I don't care about what the quotient is. I just care that the remainder was 0. So the answer is yes. X plus 4 is a factor of x squared plus 6x. X squared plus 6x plus 8 because you got a remainder 0 when you divide it. Over here, Same thing, -4 goes in the box because we're still doing x plus 4. And then you go 1, 3, -6, -7. Drop the 1. -4 times 1 is -4. You add down, you get -1. -4 times -1 is +4. You add down, you get -2. -4 times -2 is +8. You add down, you get 1. Again, don't care about the rest of the quotient. I only care that that remainder is 1. It's not 0. So that means it's not a factor. X plus 4 is not a factor of x cubed plus 3x squared minus 6x minus 7. I'll leave the rest of these for you to try on your own, but it's the same thing. You have x plus 2 as your factor, as your divisor, so you put -2 in the box, then you list out your coefficients. If you get 0 as a remainder, x plus 2 is a factor of that polynomial. If you get anything else, it's not. So I'll leave those for you to try. And we'll have something like that in the exit ticket. Now let's look at remainder theorem. It's just another use of this. What the remainder theorem states is if a polynomial p of x of degree n greater than or equal to 1 is divided by x minus a, where a is a constant, then the remainder is p of a. Okay, that probably didn't make any sense. It's okay. What that really is just saying is, well, let's recall what p of -4 means in this context. P of -4 means you take -4 and you substitute it in for x and you evaluate, and you're going to get a number as your answer. What the remainder theorem is suggesting is if you do division with -4, well, x minus -4, so x plus 4 as your divisor. So for synthetic division, we're going to be doing -4 in the box. The remainder you get is the same number you would get by evaluating for p of -4. So it's another way to do something that we already know how to do. And quite honestly, it's a faster way to do it. So what we're going to do is if it's asking what is p of -4, -4 is the number, that's the divisor. Now you list out the coefficients. Notice how there is a missing cubic term. We need a 0 placeholder for -5, 4, and 12. Drop the 1. -4 times 1 is -4. Add down, you get -4. -4 times -4 is 16. Add down, you get 11. -4 times 11 is -44. You add down, you get -40. -4 times -40 is 160. And you add down, you get 172. That is the remainder. So what the remainder theorem is saying is if you were to evaluate this function for -4, meaning you substitute -4 in for x and simplify, you would get 172. So the answer is p of -4 is equal to 172. On a written test, I would expect you to write out the answer like that. All right, and that's that. I will leave the extra ones here for you to try on your own. Or that last one. Here's a real quick summary. Long division always works, like quadratic formula always works. So you can do long division for any of the problems. Synthetic division only works with linear factors, meaning the divisor has to be x plus 3. It can't be x squared plus 3. And the leading coefficient is 1, meaning it can't be like 3x plus 2. It has to be x plus 2. So if you run into any divisors that look like that, you have to do the full long division. If the remainder equals 0, it is a factor, like in that third example. When you do synthetic division with remainder theorem, you don't switch the sign, meaning if it says p of -4, like in our example, we used -4, we didn't switch it to +4. All right, so you're going to get a few questions like these as an exit ticket. Let me know if you have any questions. Otherwise, we'll go over this all tomorrow.